Did you know you, dear audience, are very unrepresentative of the world at large? In fact, you are very unrepresentative of the developer community at large. And I'll tell you why. Everybody is writing in Python. Everyone apart from us. We write C and C++ and Rust and RISC-V assembler. But everybody else is writing Python. So if we want mass market adoption of Cherry platforms, we need to make sure they can write Python on Cherry. And that's what this talk is all about. So, let me tell you about MicroPython, which is a cut-down Python interpreter that's nice and small and simple. An order of magnitude smaller than the default CPython, which is what most people use, and an order of magnitude worse in performance as well, but never mind. It's designed, of course, for more tightly constrained scenarios, microcontrollers. So if you are the proud owner of an Arduino or a Raspberry Pi Pico, hands up. Yes, good. Then you've probably coded in MicroPython on these things, unless you're coding in C or Arduino C or whatever it is. But you can certainly write MicroPython code on your microcontroller. It supports most of Python 3, and there are lots of extra libraries, import machine.I2C and things like that, and you're away. And there are ports available for Linux. You can run it like a standard process VM on Linux, and also on bare metal and on certain RTOS systems. So, thanks to John and George and the British taxpayer, we ported MicroPython to Morello on CheriBSD, and more recently have ported MicroPython to Sonata, CHERIoT RTOS, and again, this is available now in a package repository of your choice. So it's on GitHub, it's available, and you have build instructions there and binaries, and you can also package 64C install devel/MicroPython on your CheriBSD release, I think. So this is the thing running on Morello here, and it's just a kind of standard process virtual machine on Morello, and it's running in purecat mode with type bounds around your allocated objects, which are garbage collected using a standard non-moving mark sweep collector. And in Morello, there's no live demo here, sadly, but in Morello you can use the UC types library to access raw memory in unsafe ways. But if you try and do something dodgy, then you get a capability protection fault, and everything's fine. Which it wouldn't be if you were to do that on your Arduino or Pico or something like that. You'd be able to trample all over memory, which would be terrible, of course, wouldn't it? Now, if you're very quiet, you might be able to hear a tune in a minute, because we hooked up how I wonder what you are. We hooked up a simple piezoelectric microphone to our Sonata board and wrote some Python code. This is some of the Python code there. And it's just using GPIO pins to write a very simple tune. The kind of thing that, you know, if your kiddie was opening their microcontroller on Christmas Day, they would want to do as a kind of initial coding exercise. So this is really kind of accessible coding here in simple Python that does very tangible things in a memory-safe way. How nice. So we support, in Glasgow, 4 versions of MicroPython here on CheriBSD Morello, on Linux for Morello as well, on CHERIoT RTOS for Sonata. We're a little bit behind the current release. I think we're on Sonata 0.4, so we need to fix that up for Sonata 1.1. And we also run a bare metal RISC-V CHERIoT IBEX thing, which runs in kind of non-capability mode as a baseline for comparison. We mitigate real-world vulnerabilities. So in the last 2 years, there have been 5 CVEs reported against MicroPython. 3 of these are spatial safety violations, which we mitigate. And we don't mitigate the temporal safety ones because this is temporal safety inside the MicroPython heap, which is something that we don't support. We're looking at that. Here is some kind of simple class here, which just kind of returns the index that you give it. And we take a slice of an instance of this class and then call this indices method. And you're supposed to give indices an integer, but we give it a floating point value. And there wasn't protection for this in the MicroPython code base. So there's a type confusion problem, which means that MicroPython thinks the floating point representation is an integer. Integers are kind of boxed up here, so you have a list of digits, and you can go and reference into this digit list because you think this is a boxed integer, but actually it's a floating point number, and you reference past the end of where the floating point number is in memory, and you are accessing memory in an unsafe way. But we mitigate this, so we turn type confusion into a spatial safety problem, and everything's absolutely fine. Did you know, so if you're not at university, you can go to sleep for the next minute. I'm about to moan about something, right? So in Glasgow, they're telling us that unless our papers get 5 citations a year, we can't return them for the next ref. So please cite my papers. And this one here is a very nice one. I'll cite yours if you cite mine. Don't tell them I said that. This is our compiler construction paper from this year talking about CHERIoT MicroPython, and we have some evaluation figures. So these are, I suppose, against a rather tight baseline, and perhaps we could have a lower performance overhead. So this red line here is our RISC-V non-CHERI MicroPython, and you see these larger numbers here are slower benchmark executions on our MicroPython CHERIoT runtime, and we have roughly a 1.5 times slowdown there. We think this could be better, and we're talking to friends at SCI under low risk about this. Good. So we want to update for the latest Sonata version. We want to run an Iceni when it comes out. We want to support more Python libraries, and we want to improve compartmentalization because everybody loves compartmentalization. I'm now putting on my hat as CHERI Alliance Virtual Machine Working Group Chair. At the moment, I'm the only member of the Virtual Machines Working Group for the CHERI Alliance. Please join my working group. But one of the things I want to do is to have an inventory, an online open inventory of all the managed language runtimes that are available for pure capability CHERI implementations. There's OpenJDK from Manchester and Friends. There's MicroPython. There's JavaScript Core, V8 we were hearing about. There are some WebAssembly ports as well. And I want to have a nice, easy, accessible kind of list of all the managed language runtimes that you can have on CHERI. So help me construct this list, and this will be a really nice resource for a landing page, I suppose, people who want to do managed languages on CHERI. Good. I take off my virtual hat and put on my virtual rosette. So nobody's actually said this, but vote for me. If we don't actually believe in universal suffrage in the CHERI Alliance, but if you are a voting person in the CHERI Alliance, governing board elections, then do consider as your community candidate voting for me, Jeremy Singer, University of Glasgow. Other candidates are available. Thank you. I think that's it. Good.